Good afternoon, chemists. Let's get started. So welcome to Chemistry 1210 with me, Dr. Lisa Wynn. Let me do my intro. I need to just make sure my voice is okay. All right, so lots of people here today. That's great, our first day. So just remember, we meet Monday, Wednesday, Friday for lecture at 4:10. During the week, that there's two levels, there's two stories of seating. If you go upstairs, there's a whole second level, all right? Okay, that person's not listening to me, all right? So, it's a little crowded here on the first floor, but probably mid-semester it might clear out a little bit. We'll see. So let's go over the logistics of the course, not for too long because we have a lot of material to cover in this class. So again, this is the first sequence of chemistry, general chemistry here at OSU. I am Dr. Lisa Wynn. You can call me Dr. Wynn or Dr. N. So you have the syllabus, intro syllabus slides. So I'll work through those a little bit here, but I kind of just have the big bullet points here for this course because I know we're all really anxious about this course. I mean, it's 5 credit hours. It's going to be eating up a lot of your time. So I want to make sure that our communication here and the expectations for this course are as clear as possible. So there's me, Dr. Wynn. It's pronounced like we will win the championship game because fun fact, I was a graduate student here at OSU when OSU won the CFP championship, like that first year. It was amazing. The streets were literally on fire. Everyone was best friends with each other. We were all like slapping hands, high-fiving along the street when we won. It was amazing. So that was my first year here as a graduate student. So fun fact. So my office is in Evans 1043. It's a little bit hard to find. I like to call it the dungeon, but if you follow the yellow Post-it notes, you'll find it. I will have in-person office hours every Monday and Wednesday after this class. So if you just stick around after class, we can all walk to my office together and we can talk about, more chemistry concepts or about life. So if you just follow me after class on Monday or Wednesday, I'll show you where my office is. And also, if you watched my intro video, you'll also get, if you come to my office hours, I'll give you a small little present, a small gift that will help you succeed in this course. It's not extra credit. There is no extra credit in this class, but it is a small gift and you have to come to office hours to get it. All right, okay. So there's my office hours. Do know that I actually teach another section of 1210 in this same classroom. It's another 200 students at 6:30. So be sure if you send me an email or anything, just take the half second and tell me whether you're in the 410 or the 6:30 section. Because if I have to bring up Carmen to find you, it saves me a lot of time. So please just tell me what section, what time does our lecture meet, and that'll help me immensely. So yeah, our lectures are Monday, Wednesday, Friday, 4:10 to 5:05. How our lectures are set up is, I already provide the lecture slides with blanks embedded in them, and we work through them together. What I like to do is focus on the practice problems and expand on the content that's on the lecture slides as much as possible. And so with lectures, since they're in this room, I also record them. So right now the podium is recording everything that I'm saying right now. It's recording the screen. And so about, a day or two later, I will post these lecture slides or this recording onto our Carmen page under the correct chapter heading. But I do want to emphasize that, you'll get the most out of this class if you come in person. I feel like I'm a pretty dynamic person, and you get that when you're here. That doesn't really come across in a video. Actually, I don't know. I never watch my videos. I don't like to look at myself. Yeah, come to class. Just come to class. All right. What else? Okay, so lectures recorded, blah, blah, blah. So you might have already noticed if you downloaded the lecture slides that I have a syllabus gatekeeper quiz. So you have access to this first syllabus lecture and chapter 1. But if you want access to chapter 2 and 3 and subsequent chapters, I think I already have up to chapter 3 posted already, you need to get a 100% on this quiz. Who's done the quiz already? Yeah, like at least half of you, I saw. And so what that syllabus gatekeeper quiz is just, forcing you to read through the syllabus. I know it's long. Read through all the information we give you. I know there's so much. And then get 100% on it. I feel like the answers are kind of obvious, just the way I have it written. So I just want you guys to know what the expectations are of the course. So I'm forcing you to do this gatekeeper quiz to lock out, the rest of the course content. And you'll see, especially for chapter 1, if you've already seen it, I post a lot of resources in addition to the lecture slides for each chapter. And you'll see that I'm very consistent. I'm very predictable. All of the chapters are like that. And we have 12 chapters to do here. All right, so that's lectures. Any questions about lecture? Okay, all right. Did we all have, yeah, sure. Attendance in lecture. There is no attendance in lecture. So I will show you right here, where do your grades come from? So if you bring up the course logistics slides I have right here, if we look at the grading scheme, there are no components related to lecture. We're all adults here, right? So you come to lecture, if you want. I'm not gonna run after you to come to lecture. It's your choice, all right? It's your money. It's your tuition money in the end. I want you to come to lecture, and I'm gonna allow you to make that choice. I will say you are much more likely to succeed if you do come to lecture. But what is attendance graded is recitation, and that was the next component I'll get to. So you see here on this grading scheme, recitation is 8% of your overall grade, and it is attendance based. Who went to recitation yesterday? Okay, good. At least half of you, all right? So recitations did start. They happen on Tuesday and Thursday. So the one yesterday was ungraded, so you basically you met your TA, you went over course expectations. Did you do some of the packet? Yeah, you did some of the packet. So I understand you didn't have lecture yet, but I just wanted you to understand what the feeling of recitation is. It's much different than it is right now, right? It's much different. Yes. So the point of recitation is just time to do practice problems. And so I have this guided packet to help you through that. And so how recitation is attendance graded is that there is a quiz that you just take. It's not a quiz, it's a survey where you just take it and it marks your attendance and it automatically gives you a 10 out of 10. So when you walk into recitation, let's say on Thursday, because it is graded, your recitation TA will give you the password. Let's say it's chemistry. You type in the password chemistry, you get access to the quiz, you submit it, you get your points. And so that will happen for all of those graded recitations. So do recall the recitation schedule here. I actually just updated it. All right, so before the Thursday recitations didn't have any ungraded days, but apparently we don't know how to count. So there is one ungraded day here. So based upon these days, whether you meet for recitation on Tuesday or Thursday, those black ones are the ones that are graded. There's a total of 12 graded ones. Everyone is allowed 2 drops, meaning you need to attend a minimum of 10 recitations to get a 100% in that grading category. You have to show up in person. You have to. There's no Zoom option. There's no hybrid option. There's no makeup option unless you have documentation such as a doctor's note or if you're a student athlete, then you need to come talk to me about that. But that's only something I can accommodate. Your teaching assistant can't do that. So you have to come to me if you want accommodations. But everyone is given 2, right? So that's kind of just to level the playing field within there. Any questions about recitation? Right? Oh, so there's an activity. It doesn't matter how much of the activity you do. It's ungraded. The activity itself is ungraded. How you get your points is through the attendance quiz. So you don't have to submit anything with the activity. You don't have to, be completely right in the activity. You just want to use those 55 minutes as best as possible with your teaching assistant, so you can get, the most out of that time with them and your classmates. Okay, all right, there we go. Any questions about recitation? All right, do you have other classes that have recitation? Yeah, okay, so yeah, it's similar. It's like small group activity type stuff. So I give you, the activity to help kind of structure it. Oh, and also if you take the attendance quiz, once you take the attendance quiz, if you look at the feedback of that quiz, the first question will have a copy of the key to the activity. So if you go to recitation, you take the attendance survey, you're kind of ahead of the curve there, and you have access to the key right from the beginning if you want to refer to it. I do post the key for everyone at the end of the week. All right. Okay. All right. And so if you were to miss lecture or recitation for any reason, like, you don't have to tell me and your teaching assistant those things. All right. Yeah. We're all adults, unless it's an extreme circumstance and you need accommodations, that's something to tell me. But if you're just like not feeling it and you don't feel like you don't need to tell me. All right. You don't need permission to not go. We're all adults. All right. So that's recitation. All right, so that means the other half of you went to lab. All right, I know there's a lot going on in lab. I will be truthful. I am not involved in lab. If you ask me questions about lab, I will push you towards the lab supervisor. There was even a syllabus quiz question about that. The reason, it's not that I'm lazy and I want to just not worry about it. It's because lab changes every semester and I can't keep up with it. And if I give you an answer, it's like 50% chance that it's wrong because it's changed from last year. All right, so I will tell you that I am not involved in lab, and especially if it's a logistics thing, like if you need to get excused from something. Hey, there's a second floor. There's a second floor of seating up there. Yeah, okay, all right. If it's a logistics thing, I can't touch lab. I can't give any grades on labs. I can't give any extensions. I don't do lab, all right? But I can tell you the expectations, it is with a teaching assistant. You get goggles on your first day, but you need to make sure for lab that you show up with the proper PPE or personal protective equipment. Basically, you want no skin below the belt showing. So right now, I have to hike up my socks, but this would be an appropriate attire for lab with the lab coat and the goggles. So long pants, closed-toed shoes, and your lab coat. And so that lab coat you need to purchase from Celeste 180. So in the chemistry storeroom, I think you can use a Buck ID or a credit card. You need to get that lab coat. The reason is because that lab coat is a very specific composition that is more resistant to flame. So if you had a lab coat in high school, you cannot use that in this lab. But the great thing is once you get the lab coat for Gen Chem here, this is the same lab coat you can use for all of chemistry. And it's safer than the ones that you use in biology and stuff like that. It's much more flame resistant because of the composition. Okay, so that's lab. Addition to the lab coat, make sure you purchase the Achieve Smart Worksheets thing. It changes names every term. So do make sure you get that as well. Once you purchase that, I think you get a paper copy of the lab manual. Is that true? See that? I think that also changed. All right. So make sure you purchase that as well. All right. Again, I am not confident about lab because it changes. And then yes, do the lab safety quiz. If you look through the modules, and I got a ton of emails about this, you have to work through all the pages in sequential order. If you try to do the lab safety quiz and it says you don't have the right prerequisites, it means you didn't click on all the pages. You didn't do the tasks before it. All right, so you got to do it in order. All right, so there we go. So lab is a separate thing. I am involved in online homework. Online homework is through Mastering Chemistry. 99% chance you already purchased it. All right, so you don't actually have to purchase it separately. So this is through Pearson. It was covered in your digital textbook fee when you registered for this class. So when you bought the textbook, the digital textbook fee, it comes with Mastering Chemistry as well. They come in a bundle. It's through Pearson. How my class is set up with online homework is I have one large homework set due per chapter. So we covered 12 chapters. How many homework sets are there? 12, yes. So how my homework sets are is as soon as we finish a chapter in class, that homework set is due the following Sunday, like the next Sunday, calendar Sunday. So if we finished chapter 1 today, we're not going to, okay? Then mastering chemistry homework would be just due, this weekend at Sunday at midnight. All right. So that means if we finish 2 chapters, like if we finish chapter 2 on a Monday and we finish chapter 3 on a Friday, that means there's 2 homework sets due on Sunday. All right. So it's the next calendar Sunday within there. Thankfully, all right, I really encourage you to do homework questions because it's a large homework set. I usually like them to be between 2 and 3 hours. So it's about 2 to 3 hours of homework a week. Do them as we go through the chapter. The questions that you can do, and maybe save the harder ones for the weekends or something. A due date, the due date is on Sunday, doesn't mean due date, like D-O. Like D-U-E doesn't mean D-O. Okay, you can do them now. You could do them right now. All right, they're all open. You can look at them now. You don't get penalized for looking at any questions, looking at the hints or anything. You can do them in any order that you want. And so the great thing, and I'm actually going to move to the slide that I have about homework. All right, is that I have a really lenient late policy. All right. Any questions, individual questions that are that are late, all right, that you don't complete by the due date, those individual questions get penalized 10% per day, and the max penalty is 50%. That means, in theory, you could wait until the very last day of the semester, do all of the homework, and still get 50%. All right, so that means if you're, it's Sunday night, it's 11:30, and you're only halfway done with the homework assignment, you can keep doing it after midnight, and you'll just get a very small penalty on all of those late questions. I'd rather you guys do questions than not do homework at all, all right? Okay, all right. So that's what I have highlighted there. So that's partial credit. It's only for individual questions that are late. All right, so if you do all but one question on a homework assignment, all of those questions you did before the due date, you get full credit for it. It's only that one question you did late will have the penalty, right? So it pays off to do questions early. All right, so registering for online homework, find the instructions on our Carmen page. I think over half of you have already done it. Yeah. Yes. So the question was, can you redo homework questions to study for the exam? Yes, you can. Once you submit a question, there's a way you can click a button and it says practice. So you can rework the question, like it might have new numbers. You can rework it and it won't change your score or anything. I will point out that the department and I personally, we post a ton of resources for exams, and I would prioritize the resources we post over online homework because the book publishers publish that. And so you want things that resemble an exam more. Does that make sense? Yeah. Okay, all right, good. All right, and so here, if you look, when you registered for this class, do you remember this digital textbook fee, $56? Did you have an option to opt out of it? You didn't know? Well, I'm assuming it's already paid for too. I think before there was an option to opt out of it. So I'm hoping you didn't. So that's what I'm saying. Like, you already paid for this. You already paid for the book. You already paid for online homework. You just have to go through the process of linking your Carmen account to a new Pearson account. And so that is on your start of term tasks. So in addition to homework, all right, we also have the online textbook. All right, and so that you can access through Mastering Chemistry, the online homework portal. And this is important, especially if you're on a computer. All right, and you go to the Mastering Chemistry portal. If you click e-textbook, it'll bring up the book. All right, but what it also shows, and this year this is something new that I've implemented, I have notes in the book. So you can see, you know, my notes, my comments on different concepts, or maybe I expand on some of the examples, so you can see what I write as well. And I'll point out if I write a note about it, about some concept, it's probably important, right? All right, so I've annotated, I think, up to chapter 3, and I'll keep annotating it as I go. So that's our textbook. Each section, it's really nicely laid out, has sample exercises, and at the end of each chapter, there are section summaries. This is really important. We go fast in this class. We go real fast, all right? It's, you know, if you're used to high school chemistry or whatever, like, we go 3 times the speed. When I say the word electrolyte, we don't spend a week on electrolytes. I assume that you are an expert in electrolytes by the next class, because we're using that concept again and again and again. So a good method to get the most out of this lecture, because if I'm talking about some chemistry concept and you have no idea half of the words I'm saying, it might be useful to kind of introduce those concepts, those terms to yourself before coming to class. You don't want to hear the term electrolyte for the first time here, where I say it 50 times in one class, right? So those section summaries you can read, and it's kind of giving you like a preview to what's to come in this class. So, you know, when you're sitting here in the audience, you're not just completely lost about what's going on. We go real fast in this class. You may talk to others taking this course, or other folks who have taken this course, or you might talk to your classmates and they might say, oh, I took AP chemistry, this class will be a breeze. I'm sure you heard that. You've heard that from folks. And then you might be sitting there, well, I never took AP chemistry. Does that mean that I will not succeed? That's not the case. I have a PhD in chemistry, and I never took AP Chem in high school. I never did. Does that make you feel better? And I think I turned out okay. All right, that's a joke. All right, okay, there we go. So section summaries, it's reading that, you know, it takes 5 minutes to look over those key terms, the summary of each section, so you know what we're gonna be talking about in class, all right? Just take 5 minutes, okay? I'm not asking you to teach yourself these concepts before coming to class, that's my job, all right? I just want you to be like a little bit prepared, do a little bit of front end work before coming to class. It'll pay off so you can get more out of these lectures. This is a new section within the textbook. It's called exam prep. All right. These are each chapter has like 20 examples of exam type problems that you can do to prepare for exams. I would suggest doing those right away. Don't try saving those for the exam, because when the midterm exams do come up, don't worry, there will be plenty for you to study from. I will post 3 practice exams. I think the department also posts 3 practice exams. All right, so these exam prep questions in the textbook, don't wait to take them. Don't like save them, because you will get plenty of practice questions. All right, and then of course the end of chapter exercises. These are just, you know, questions to elevate your learning, not so much catered towards exam style questions. All right, so what about exams? Our exams, we have 3 midterms and a final. All our midterms are equally weighted. They are all, you know, there's I think 9 different Chem 1210 sections. We all take the same exam. So all, I think 6 professors, we all get together, we write the exam together, and it's all 1210 students take the exact same exam. So I am not writing all of the exam. That's what I'm trying to tell you right now. But we all cover the same material, don't you worry. So each of the midterms are equally weighted, and then our final is worth 20%. If you've talked to previous Chem 1210 students, this has changed from previous years, just so you know. All right, some questions I oftentimes get here, are the exams curved? No, they're not. And then the other question I get is this class curved? No, it's not. So this is something new, kind of. You might talk to other Chem 12 people who've taken 1210 and they're like, oh yeah, the curve is real good in this class. It's not, all right? We've been putting the grade cuts in the same exact place for the past 10 years. All right, and students think that that's a curve. It kind of is. It's like, to get an A minus, instead of getting a 90%, you only have to get an 88%. All right, so there is, I guess, kind of a built-in curve, but this year it's new in that we are displaying the grade cuts from the very beginning. You know exactly how many points you need to earn to get the grade you want. It's not a curve, all right? It's not a curve. We use a different scale. All right, than the university scale you think of. Like, we think of an A as a 93%, but in this class, you only need a 92. To get, those are the only ones I can think of right now. An A minus, I think you need an 88% instead of a 90. So it's transparent from the very beginning. There's not a curve, right? You can think of it like a built-in curve, but those are the points that you need to get, and I've shown here the grading categories that we have. So this is in the syllabus, and I describe it on my page as well. So you can see that the big assessments here are midterms. We do have a very important calculator policy here. These calculators are the only calculators you can use for exams. No exceptions. It's only the TI series. It has to have a 30 in it, an 83, or an 84, and that's it. No TI Nspires, no Casio calculators. These are the only ones. Very important, okay? Because if you try bringing a TI Nspire to the exam, I will take it from you. And you will not be able to use a calculator on the exam. I will be checking, I will have my recitation TAs check your calculators to make sure you're using the appropriate one for the exam. So this is important to help us maintain academic integrity. The reason the TI Nspire is not allowed is because of the keyboard. Yes?
So just for the grades?
Yes.
Is there a difference in GPA between like A or A minus?
Yes, yeah, so an A, I think, is a 4.0, and how that's factored into your overall GPAs through like a weighted average of the different credits of, the courses. So this is a 5 credit hour course. So, an A in this course has more weight than an A in a 3 credit hour course. An A minus is a 3.7. And then I don't know what it is after that. Yeah, okay, yes.
Is TI 30 multi-view all right?
Is it one of those? Check the syllabus. If it's one of the ones listed, then yes. If it's not, then no. I'm sorry. All right. But don't worry, like for homework, for lab, it doesn't matter what calculator you use. It's just for the exams. But it is important that you are comfortable using these calculators for the exam. So like, don't buy a TI, 83 the day of the exam, and you don't know how to like put in an exponential or something. That would be awful. So there we go. All right, so plenty of time. I will definitely have the recitation TAs check on you with that. All right, so this is long enough. So the resources for you, okay, my suggestion for you for this class, do a little bit every day. Do a little bit of chemistry every day, okay? I tried cramming a lot in my undergrad when I was a student, and it didn't turn out really good for me. I mean, it was okay at the beginning, but then, I still tried cramming before all my exams, my midterms, and it caught up to me real fast. All right, so do a little bit every day to keep up, advocate for yourself. I'm here to help you in my office hours or through email. Your TAs, they're experts to help you through this material as well. There's a large support here, all right? So my in-person office hours are after class Monday and Wednesday. I might do Zoom office hours too. I haven't decided when yet, though I'll announce that. Also, the Learning Resource Center is the TA office hours where there's a fleet of TAs in Celeste 170, basically 9 to 5 every day. And they also have Zoom hours too. And these are drop-in tutor hours, all right? So you don't have to go see your TA. You can go talk to any of the TAs there and they can help you. The textbook, Mastering Chemistry, is a good resource for you. And also I post tons of resources on our Carmen page, usually by chapter. All right. Any questions? Any questions? Okay. Actually, before I get started, let me show you where to find the chapter, the lecture slides. No, that's not where I want to go. So to find the lecture slides, all right, you go to our Carmen page. Okay, load. Let's go to our Carmen page. Man, I talked way too long. I need to save 5 minutes to blow up that balloon too. So this is what you get for coming to class. I will do demos, I'll blow up stuff, all right? So that's fun, all right? You don't get that when you just watch the recording. All right, so here's our Carmen page. Mine looks a little different because it's teacher review. But everything that I post for you guys, it's under our Carmen modules. Everything is under modules. So you see here, first week of lecture, I have some, resources for you, some information, and then lecture resources by chapter. Every chapter page will look like this, where I post the lecture slides, the homework set, and different supplemental information. So here I have some practice problems, similar to how they are in the book. I talk about the learning objectives for this course, but yeah, bunch of different practice problems. But what's great is that there's a worked out key right next to it, so you can check and assess yourself, your understanding. It's a very detailed key, all right, so that's all my stuff. So that can help you as you're working through, homework. You might find a very similar looking homework question on these overview sheets, hint, hint, right? And other resources. So Dr. Stolzfus, who's another lecturer here, he was the guy who was standing right here for forever, all right? He also posts supplemental lecture videos for every single section of our textbook. He's an author of our textbook as well. So here are supplemental lecture videos, although, it's a different lecture talking about the same concepts here. All right, and then on this page, you will also find the lecture recordings, these, but I have to post them. All right, so give me some time, give me like a day. I'll probably post them the next morning or something, and you'll find them on this page. All right, so let's get started. So here we'll start with chapter 1. So you can choose 1 page per slide or 2 slides per page. I'm a 2 slide per page girl. Oh, I forgot to describe my dream board. Here's my dream board where I introduce myself. So if you want more information about the syllabus slides, I have like a 30-minute video on it on our Carmen page. All right, if you want, I go into detail of each and every single slide. Here's my dream board. I talk about my cats all the time. All right, those are my 2 cats. My 3 favorite places on earth is my farm, Disney World, and Costco. Okay. Those are 3 of my 5 chickens. I had to give 2 of those a bath yesterday because their butts were really gross. I had to give them a bath, and it actually wasn't that hard. All right, it was the first time I did it, but it was actually easier than I thought. I thought they'd be like flapping everywhere, but once I put them in warm water, they chilled out. All right, and those are my cats. I love to cook those things. Yeah, I live on a farm, or I like to think I live on a hobby farm. All right, and I was named after Lisa Simpson. That shows my age a little bit. Okay. But call me Dr. N. All right. Okay, so that's my dream board. All right. So let's start with chapter 1. Chapter 1. Remember, we will be covering 12 slides or 12 chapters. At the beginning of every chapter, you'll see this. I typically put what you need to memorize at the very beginning, because I don't want us to get to metric prefixes and be like, you need to memorize this, and I expect you to memorize it the next day. I mean, that's the pace we work at in this class, so that's why I write it at the very beginning, all right? What you need to memorize. And what you'll soon learn here is I hate memorizing things. And so I recognize when there are instances where you just have to memorize something. And in this case, you just have to memorize the metric prefixes. I'm sorry, all right? But I will tell you that, and again, I hate memorizing things. I will, do whatever I can to prevent memorizing something, and that means actually learning the concepts. That's how you don't have to memorize something, is by learning the concepts. All right, so let's learn the foundations of chemistry here. Why do we study chemistry? And talk about energy matter and measurements, I guess. All right, so here are the different sections. So first, just to kind of set the tone of this class, the study of chemistry, you see that it's kind of central to a lot of different topics, a lot of different fields. You may look at this like web of topics here, and you might see your own major. I recognize, not all of you are going to be chemistry majors, I know. You have probably your own major. Your own field of interest, but I'm still in this classroom. I'm still going to call you all chemists because we are chemists in this classroom, and I want you to think like a chemist in this classroom, and I hope that I can teach you how to, or mold you into thinking like a chemist and looking at the world around us through the lens of a chemist. So you might look at this map and see your own specific field and how it is kind of interconnected to chemistry. If you're an engineer, recognize that chemistry and the study of matter and its properties are the reasons why we choose, one material over another material in terms of like cost manufacturing, saving money for your company or something like that. It all has to do with chemistry, and it's really chemistry is really central to a lot of topics here. That's why we call it the central science. I had the textbook up a little bit ago. What's the title of our textbook? Chemistry, the central science. All right, it's central to a lot of different topics. Okay, all right. I like to think of chemistry, why I love chemistry, is it gives me the tools to answer just random curiosities, random questions I have about the world. So like here's just a list of things that I thought of over the past week or so, of just things that have been on my mind, all right? And then when I go look up the answer, I see that there are a lot of just chemistry terminologies there. And I think that's kind of like the beauty that chemistry gives us the tools to answer, these kind of things, All right, so why do only diesel engines roll coal? I thought that was pretty interesting, all right? We'll talk about that later in chapter 3. Right. Did you know that? Did you know that only diesel engines can roll coal? Do you know what rolling coal is? Okay, it's like when you're on the highway and then someone cuts you off and goes and goes really, real fast, and they have a black cloud of smoke behind you. That's called rolling coal. Only diesel engines can do it. Okay, so you can sound real smart in front of someone. Okay, like me, I sounded really stupid. I was driving with someone who drives just a regular truck, and I said oh, roll coal, and they're like, this truck can't roll coal. And then in my mind, the inquisitive person me thinks, well, why? And it has to do with chemistry and limiting reactants, and we'll talk about that later in a different chapter. I'll show you the tractor I bought last year. And then I asked my husband, I'm like, because the tractor it runs off of diesel. I was like, can you roll coal on that? And he's like, yeah, of course. And then we can roll coal on the tractor. Okay, there we go. All right. So you don't have this in your slides, all right, the map of chemistry. I just like this cute little diagram. There's a lot going on here. On the green side are all the concepts, the foundational knowledge, the rules of chemistry. This is what you're going to be learning in 1210. How many of you are taking 1220? Okay. Wow, not a lot of you? Less than half? Okay. All right. So you have to take 1220 to see to explore the rest of the green portion. But the yellow portion on this other side, these are applications of the rules of chemistry. I hope as you're sitting here thinking about, your major and how chemistry fits within your major, all right, hopefully you can see, some of these concepts that we're going to learn here in this class kind of fit within your major. So why don't you talk to someone, okay, chat with someone near you, someone you don't know, right, someone you don't know. Introduce yourself to someone you don't know. Tell them what your major is, or what you want to be when you grow up, all right, and come up with one idea of how you think chemistry might relate to your major. So take a couple minutes to do that. Someone you don't know. Oh, yeah. Does anyone want to share their thing? Does anyone want to share? Anyone want to share? Anyone want to share? Anyone want to share? No one? No one wants to share what they want to be when they grow up? Yeah. Okay. Oh, wait, here. Okay.
Oh, I'm going to go into entomology,
What is that?
study of insects.
And how does that have to do with chemistry?
I had to take this course, and I think pesticide use has a lot to do with chemistry, so I think, that's going to be a lot. Pesticides are going to be a big part of the course of entomology, I believe, so.
Absolutely, I agree. I actually did a talk on DDT, which is a chemical. All right, yeah, bad, and why how the use of DDT led to cats being parachuted onto this remote island because DDT, yeah, what? It is banned now, yeah. And so, yeah, it's like an endocrine disruptor in. Yes, and it disrupts, that's just one component of the ecosystem that it's disrupting, but so it's like, there's a children's book on it. It's like the day they dropped cats on Borneo, which is an island. So they dropped cats on it because it disrupted their ecosystem, like the insects, they were trying to control malaria, and mosquitoes, but it messed up just the whole ecosystem, and then there was like a plague of rats, and then there were no cats, so they just dropped cats on the island. I'll show that someday, okay? All right, so good. There's our insect guy. Cool. What you'll learn here, I'm not a fan. I love chemistry. I don't like so much like biology and like living things. I'm real good at like the non-living things on the periodic table. Real good at that. But like once it gets too much of like living things, I'm just not a fan. All right. I'll do my best to try to relate it to chemistry. If your passions are living things, please share that with me and how, chemistry has to do with that. Try to, change my mind. But yeah, I'm not a fan of living things. So like this part of this map, not a fan. I'm like more over here and in the physics realm of types of things. If we look at the periodic table, I'm more of a fan of the stuff on the left side, not so much on the right side, okay? Once you get into organic chemistry, you study the right side of the periodic table a lot, okay? But I'm a fan of the other side. Right. Those things are not living, they don't have feelings. That's what I'm into. Okay, so study of chemistry. So that kind of sets the tone for this class, why we're here. Yes, it's part of our degree, audit. We have to take this class, but hopefully you can kind of gather some tools and skills from this class as well. So the study of chemistry, we are studying matter, anything, literally anything that you can touch, okay, if you can put in a jar, all the stuff around us, that's what we're studying. Everything around us is made of chemicals. So I'm like not a fan of chemophobia, like people who are afraid of chemicals. We are made of elements, of chemicals technically. Yes, there are some bad chemicals, but there's also a lot of good chemicals that sustain life. So that's one thing that chemophobia, not so great. All right, so chemistry, study of matter. So matter is just anything that has mass or occupies space, literally anything you can put in a jar. All right, anything you can hold, that is chemistry. But if we go into the nitty-gritties here, we're not just studying, the existence of matter, but we really want to understand its function. We want to look at, its structure and composition, and observe the properties that we can see. So a lot of the rules of chemistry that we'll see here is how composition and structure relate to the properties of matter that we see. That is the secret to chemistry that I will continue to bring up in subsequent chapters, that it's the composition, so the atoms or elements that make up the matter, and its structure. So how are those elements or atoms bonded to one another? So composition and structure dictate the chemical properties and behaviors that we see. And we'll see this over and over and over again. It's what it's made out of and how it's connected is what tells us how things behave. All right, and that's the secret to chemistry, composition and structure. All right, so let's chat about the ways we talk about chemistry. I believe this is why chemistry is hard for so many people. It's because we are talking about matter in a bunch of different domains, meaning we're using a bunch of different languages to describe what we're seeing. So the first one is the macroscopic domain. This is what we can see, what we can sense, meaning we're using our eyes, we're using our nose, we're using our ears, I guess. We're using our senses to see behaviors, like if we see the color of a substance, or we can smell a certain type of substance, or if we can see a chemical reaction occur. That's the macroscopic domain, what we can see. The problem is, and where it gets difficult, is when we think about how atoms are bonded together, we can't see atoms. We can't see atoms, we can't see individual elements, so we need special instruments to help enhance our vision so we can see these particles. We can't actually see them, so we actually have to just imagine them. So we're taking these observations that we can see with our mind, see with our eyes, and we have to translate that into a particle view of something that we can't actually see. We actually just imagine it. We're just making up these shapes in our brain. All right, that's pretty hard. We're taking something we can see, transforming it into something we can't see, and visualizing what's happening on a particle scale that we can't actually see. And now to make even things harder is how we communicate with one another on, how things exist in the particle realm, how things exist in the macroscopic realm, is we use symbols to denote that. Right? We have to use symbols, a new, different language to communicate with other folks. What substance am I talking about? What is its state of matter meaning? So we are using these fancy symbols and characters to represent things that, one, we can't even see. We have to just imagine what these molecules look like on a tiny particle scale and relate that to what we can see on a macroscopic scale. Okay, that's why chemistry is hard. We're taking big to small and then using symbols to represent them. And we are constantly working in these different realms all at once at the same time. All right, so in this class, we're learning 3 languages at once, I guess. Okay, all right, there we go. Okay, so let's, kind of put this into practice, the different domains of chemistry in this picture, the macroscopic view. What do you see? What do you see? Boiling water, yes, very good. We can use symbols to represent that. We can use a chemical reaction to represent boiling water. What that is actually showing, or what's happening when we boil water, is we're taking water, which has the chemical formula H2O, so that's a symbol, and we're saying it's turning from a liquid to a gas. So that's what we see right here. Okay, finally I got to write something. All right, this is our symbolic view. And what that is representing is our macroscopic view here, boiling water. It's turning a liquid to a gas, and how we represent that is with those symbols within there, which we'll go into more detail in a later chapter. Also, what's happening here, we're burning methane, so here's another chemical reaction that's happening too, right? But the main focus here is water boiling. So that's the symbolic view. Here's what we see, the macroscopic view, but we can also imagine what these water particles look like in a microscopic view, meaning we're looking at the individual particles. So like liquid, water in the liquid phase, those particles are much closer together. That's what this particle view is saying. And in the gas phase, the water particles are further apart. So your brain needs to interpret that as well. If I say water gas, you need to think of the particles further apart. If I say water liquid, the particles are packed together. What if I said water solid, or as us mortals call it, ice? They're close together, but also they're not moving like past one another as much. So our mind needs to, think of that if we're comparing liquid water to solid water, they're both packed together, but one is not moving as much, moving past one another. That would be the ice. It's still moving, it can vibrate, but those particles aren't moving past one another. So that's why chemistry is hard. Okay. All right, so let's do these 2 slides and I'll blow something up. Okay, so what are we studying? Okay, matter. There's a lot of different ways that we can describe matter. All right, we can talk about the states, solid, liquid, or gas. And remember that kind of translates to a different picture of that microscopic view of how those particles are arranged. We'll talk about that in terms of energy here later in this chapter and a lot in chapter 5. Also, so in addition to the state, solid, liquid, gas, we can talk about the different categories of matter, the different ways we can categorize them. So basically there's 2 really broad categories, pure substances and mixtures. When, as chemists, you want to study pure substances, okay, you want to, because you want to know all the observations that you see are pertaining to one substance. That's what a pure substance is. But unfortunately, it's difficult to get our hands on pure substances. Okay, so typically in this class, even in lab, most of the materials you work with are actually mixtures, where there's different pure substances present. So within pure substances and mixtures, there's 2 additional categories. Pure substances, we have elements and compounds. Mixtures, we have 2 different types of mixtures, homogeneous and heterogeneous. I'll go into detail of all of those in a little bit. Homogeneous mixtures are also called solutions. Okay, all right, so let's go back to states of matter and kind of expand. I should have had the slide a little bit earlier, though. When we talk about states of matter, okay, how we can observe substances, solid water, liquid water, gaseous water, we think about those particles packed a little bit differently. All of those different states of matter will behave a little bit differently. Here you also see, what is this, a plasma? Okay, so plasmas are more energetic than gases. We will not study plasmas in this class. That's the last time I'm ever going to say plasma in this course. Okay. So we will mainly be talking about solids, liquids, and gases and how they have different properties here. And so we mentioned with particle motion, right, gases, they are moving very fast, right? They're fast, lots of motion, lots of motion. When you think of gas particles, they're bouncing off one another, okay? So when we think about solids and liquids, all right, that there's not as much movement, not so much movement. Liquids more. Liquids will have translational motion, and solids here will only have vibrational motion. Right, so they're still moving a little bit, but not as much as gases. Gases have the most motion within those samples. And this really has to do with the energy of those samples, and we'll talk about kinetic energy here in a little bit. All right, and so with the energies of our samples, when we change the energy of our samples, we can see that this translates into the motion within those particles that we see. All right, so let me just quickly show this slide right here, all right, within the different classifications of matter that we have. We have our pure substances and we have our mixtures. My trick here for pure substances is if you can represent it with one chemical formula or one symbol, it's a pure substance. So if I have water, what is the formula of water? H2O. Is that a pure substance? Yeah, because it's just one formula. One formula. Okay? A mixture is two pure substances that are not chemically combined. So remember, a pure substance is something that you can represent with a symbol or a formula. So right here, this balloon has H2 in it, so it has H2. Is that a pure substance? Is H2 a pure substance? Yes, it's a chemical formula. And it has O2 in it. Is O2 a pure substance? But they're in the same sample. So technically, this balloon contains what? Is it a pure substance or is it